Lines. We start with the formula for the slope of a line. The slope m of a non-vertical line that passes through the points A and B with the coordinates that you see here is m equals rise divided by run, and the rise is defined by y2 minus y1, and the run is defined by x2 minus x1. And the slope of a vertical line is not defined. So if you have a line like you see here and 2 points A and B with coordinates, what you're doing is you're figuring out the vertical change when you go from this point to this point and the horizontal change, and then you're simply dividing those two things. And it doesn't matter what 2 points you pick. So if I choose 2 different points, say A prime and B prime, the same formula applies. Next, we can talk about classifications of slope. Any line, as you look at it from left to right, that is rising will have a positive slope. Any line that is falling will have a negative slope. If the line is flat, we say the slope is 0. And once again, if you have a vertical line, it has no slope, or you can also say the slope is undefined. For our first example, let's find the slope of a line that passes through the points P and Q. Let's keep in mind that slope is y2 minus y1 divided by x2 minus x1. Now, just for clarity, it doesn't matter which of these points you call the first point and which one is the second point. The main idea is you're just subtracting the y values and subtracting the x values in the same order. So for example, if I think of Q as being the second point and P as being the first point, I'm basically just subtracting in this direction. And so when I do y2 minus y1, that would just be 5 take away 1. And x2 minus x1 is 8 minus 2. And this is 4 divided by 6, which will simplify to be 2/3. But I also could have subtracted the other way. So in other words, I can subtract this way. And this is kind of like thinking about P as being your second point and Q as being your first point. So when I go to do the subtraction, I'm just going to do 1 minus 5 instead of 5 minus 1. But then I'm also doing 2 minus 8 instead of 8 minus 2. And when you do this, you get negative 4 divided by negative 6, which also simplifies to positive 2/3. So it doesn't matter the order in which you subtract as long as you are consistent and you subtract the x and y values in the same order. Next, we discuss the point-slope form of the equation of a line. So the equation of a line that passes through the point x1, y1 and has a slope m is given by the equation y minus y1 equals m times the quantity x minus x1. So we can use this equation to find the equation of a line. So in example A here, we have find an equation of the line through the point 1, negative 3 with a slope of negative 1/2. So you can think of m equals negative 1/2, and then the point 1, negative 3 is the same thing as saying x1 is equal to 1 and y1 is equal to negative 3. And then we're just going to plug those quantities into this equation. So that gives us y minus negative 3 is equal to negative 1/2 times x minus 1. This is y plus 3. And now if we distribute here, we get negative 1/2 x plus 1/2. And as our last step here, I can subtract 3 from both sides, and that will give us y equals negative 1/2 x. And then 1/2 take away 3 is negative 5/2. So even though we use the point slope equation of a line to get the equation, we typically solve for y when we're finished. All right, let's take a look at the second part, which says to sketch the line. So to sketch the line, I'm simply going to go back to the given information. We have the point 1, -3 is on the line, and the slope is -1/2. Now remember, -1 is what you think of as the rise, and +2 is what you can think of as the run. So from this point, we are going to rise -1. That actually means we're going to go down 1. And then run is left and right. So in this case, it's +2 in the bottom. So we're going to go down 1 and then to the right 2. And that will give us a second point. And for a line, of course, all you need is 2 points. So here is the graph of that line. Now let's talk about finding an equation of a line through 2 given points. So one thing you always need to find the equation of a line is you need the slope. Okay, so in this case, notice the slope is not given. So we're going to find the slope by using the slope formula. Oops. And to do this, we're going to subtract our y value. So I'm going to take my y value here, subtract my y value here. So that's 2 minus -4. And then we'll take the x value here, which is -1, and we'll subtract the x value here. So -1 minus 3. This simplifies into 2 plus 4, which is 6, divided by -4, and this reduces to -3/2. So this is our slope. Notice that when I divided, I canceled a 2 here, but then I also moved the negative to the top. We don't like to keep the negative in the bottom of a fraction. All right, so from here, we can go back to our point slope formula to find the equation of the line now. So we know that our slope is -3/2. Okay, so we have that part. Now we need a point, x1, y1, so that we can plug in these other parts here and here. And you can use either one of the original 2 points. They will both give you the same answer. So I'll use this point, and then if you want, you can check it with this point to see if you get the same thing. So for this point here, x1 would be 3 and y1 would be -4. So we'll put a -4 here, and we'll put a +3 here. So this becomes y plus 4 is equal to, we're going to distribute, so -3/2 times x, and then -3/2 times -3 is +9/2. And then finally subtracting 4 from both sides, we get y equals -3/2 x plus 9/2, take away 4 is +1/2. Another important form for an equation of a line is the slope-intercept form of the equation. So first, let's just consider a graph. If I have a line that hits the y-axis at the point 0b, so b is the y-intercept, and suppose that line has some slope m, it turns out that the equation of that line is y equals mx plus b. So anytime you have an equation of a line in this format, you can easily determine the slope of that line, and you can easily determine the y-intercept for that line. So for example, find an equation of a line with slope equals 3 and y-intercept equals -2. So to do this problem, we just need to remember y equals mx plus b. In this case, they're telling us the slope, which is m, is 3, and the y-intercept, which is b, is -2. So if I just plug those quantities in here, we get y is equal to 3x plus -2 or -2. And then in part B, it says find the slope and the y-intercept of the line 3y minus 2x is equal to 1. So remember, if I have the equation of a line in this form, I can easily determine the slope and the y-intercept. So basically what we need to do here is solve for y. So to solve for y here, I'm going to add 2x to both sides. And when I do that, we're going to get 3y is equal to 1 plus 2x or 2x plus 1. And then to solve for y, completely, I'm going to divide both sides by 3, which will look like this. And that gives us y equals 2/3 x plus 1/3. And so now we know the slope of this line is 2/3 and the y-intercept is 1/3. And for the y-intercept, you can also write that as a point 0, 1/3. Vertical and horizontal lines are special. So an equation of a vertical line is simply x equals a number. Okay, so that would be the vertical line through some point AB. It's just going to be x is equal to the x coordinate of the point. And a horizontal line through the same point AB is just going to be y equals b. So for example, an equation for the vertical line through the point 3, 5 is x equals 3. Okay, and just a quick diagram here. If you have the point 3, 5, which looks like this, the vertical line that goes through this point is going to be the line where x is always equal to 3, right? And so that's why the equation is x equals 3. All right, and the graph of that, of course, is just x equals, a vertical line, through x equals 3 on the x-axis. An equation for the horizontal line through the point 8, -2 is simply y equals -2. So again here, just a quick diagram. 8, -2 is this point. And if I want the horizontal line, it's going to look like that. And you can see that that is the line where y is always equal to this value. Y always equals -2. Okay. And the graph is, again, just a horizontal line through y equals -2 on the y-axis. So these are special lines, but pretty simple, pretty basic. The general equation of a line can be thought of as an equation ax plus by plus c is equal to 0. And also, I would like to say that in some textbooks, they will not talk about the general equation. They'll talk about the standard equation of a line. And the only difference is they take this number and they move it over to the other side. Okay, so you could think of it kind of in either format, but this textbook chooses to use this format. Okay, how can I graph an equation of a line that is given in this general form or general equation? Well, there's a couple of different ways you can do it. So let's first consider 2x minus 3y minus 12 equals 0. I personally don't like this form very well, so what I'm going to do is just add 12 to both sides, which will change it into kind of this format, and that's going to be 2x minus 3y is equal to 12. Now, one really simple way to graph a line is just to find the x-intercept and to find the y-intercept. And it's very simple in this case. To find the x-intercept, remember, all we have to do is let y equal 0. And you can just imagine here, if you plug in y equals 0 here, this is going to go away. And you'll end up with 2x equals 12, which means x equals 6. So that's the x-intercept. And then to find the y-intercept, we're just going to let x equal 0. And imagine if you plug in x equals 0 here, this is going to go away. So it becomes 0. And you'll just have negative 3y is equal to 12. And if you divide both sides of that equation by negative 3, you end up getting y equals negative 4. Now, these are the x and y intercepts of the line. And so if I want to graph it, I just have to graph those intercepts. So here's x equals 6. That's the x-intercept. Y equals negative 4. That's your y-intercept. And then the graph would just be the line going through those 2 points. Now, there is another way to graph this equation. All you would need to do is take the equation you have here and solve for y. So 2x minus 3y equals 12. If I subtract 2x from both sides, we get negative 3y equals negative 2x plus 12. And then we can divide everything by negative 3. And if I do that, we get y equals positive 2/3 x minus 4. And now we can see the slope of this line is 2/3 and the y-intercept is -4. So notice the y-intercept is this point here. And the slope is 2/3. We can represent that by moving from this point to any other point. You're going to go up 2 to the right 3. Up 2 to the right 3. You can see we're getting the same line. So I can either use this so-called intercept method, or we can solve for y and use slope and y-intercept. Parallel lines are two non-vertical lines that have the same slope, okay? So two lines are parallel if they do not touch each other, they do not intersect, and the only way two lines can not intersect is if their slopes are the same. So basically, if line 1 is parallel to line 2, this means the slope of the first line must be equal to the slope of the second line. So let's do an example. Find an equation of the line through the point 5, 2 that is parallel to this line. All right, so we know that parallel lines have the same slope, so what we need to know is, what is the slope of this line here? Well, to get that, we can take the equation of that line, and we can solve it for y. So to solve for y, I'm going to subtract 4x, and I'm also going to subtract 5 from both sides. And then we'll divide by 6. So when we divide by 6, it will look something like this. And then I can simplify. -4 divided by 6 is the same as -2/3. So the slope of this line is -2/3. So what about our line? Now, when I say our line, I'm talking about the one that we're trying to find. Well, we know it goes through the point 5, 2, and we know it must have the same slope as this other line, which we just figured out was -2/3. So to find our line, I'm just going to take that information and plug it into the point slope formula for the line. Same thing we did earlier. And we'll go ahead and distribute here. Carefully. And then we'll add 2 to both sides. And this gives us y equals -2/3 x, and then 10/3 plus 2 is 16/3. And so this is the line that passes through this point and is parallel to the line that was given to us. Perpendicular lines are a little bit more complicated. So two lines are perpendicular, say line 1 and line 2. When they meet to form a 90-degree angle, okay? So a right angle. If the angle between these two lines is 90 degrees, then we say that they are perpendicular. So what do we know about perpendicular lines? Well, if you think about it, the slope of one line is positive and the slope of the other line has to be negative. So the slopes are going to have opposite signs. And also, whatever the rise is for one line, it's going to become the run on the other line. So if I draw a little triangle here for the slope, the slope triangle there, I want you to notice that the rise here is the same as the run here. And the run here is the same as the rise here. So what I'm saying is, if the slope of one line is, let's say, a over b, the slope of the second line is going to have to flip that and also be opposites, okay? Now, another way to say this is the slope of the second line is the negative reciprocal of the slope of the first line. But I find this way of thinking about it to be a little bit more useful. Now, if you have a horizontal line, any line that's perpendicular to that will be a vertical line. So in other words, one line will have a slope of 0 and the other line will have no slope at all. This is a special case. So as our first example here, let's show that the points P, Q, and R are the vertices of a right triangle. All right, so to show this, we need to show that the two of these lines meet to form a right angle. So we need to show that two of the lines are perpendicular to each other. So let's go ahead and graph these points just to get a feeling for what we're doing. So the first point P is at the point 3, 3. That's right here. Q is at the point 8, 17, which is right there. That's Q. And R is at the point 11, 5, which is right there. Now, if you connect these 3 points, you can see that we have a triangle. We want to show that this is a right triangle. Now, if you're looking at this picture, it looks like the right angle is probably right here, correct? I mean, this does not look like a right angle. This does not look like a right angle. So I'm going to try to show that the line through the points Q and R is perpendicular to the line through the points P and R. So to do this, I'm going to find the slope of the line QR. And to do that, we're going to use the coordinates for Q and R. And the formula says you take the Y value minus the Y value divided by the X value minus the X value. And if you do the math here, you get 12 divided by -3, which is -4. Okay, so that's the slope of this line. Now let's find the slope of PR, this line here. So the slope of PR, same idea. Now I'm using P and R. Whoops, R is this point here. There we go. So I'm going to subtract the Y values. So 3 take away 11. And then I'll subtract the, excuse me, that's the X values, isn't it? 3 take away 11 is the X values. And then 3 take away 5 is the Y values there. This is -2 divided by -8. And that simplifies to +1/4. So the slope of this line right here is +1/4. So notice that one slope is -4/1 and the other slope is +1/4. This means that these two lines are perpendicular. And perpendicular lines form a right angle. And any triangle that has a right angle, so there's a right angle right here, is a right triangle. Okay? Next, let's find the equation of a line perpendicular to a given line. So we want to find an equation of a line that is perpendicular to this line and passes through the origin. Okay, so first thing we need to do is find the slope of the given line. So 4x plus 6y plus 5 equals 0. We're going to solve for y here. Solving for y gives us 6y equals -4x minus 5. And then dividing everything by 6, we get y equals -2/3 x minus 5/6. I believe this is the same line that we solved for in a previous example. So the slope of this line clearly is -2/3. So for our line, what's the slope going to be? Well, we know that our line is perpendicular to this line. So if the slope of this line is -2/3, the slope of our line is going to be +3/2. And then they did tell us that they wanted to pass through the origin. The origin just means the point 0, 0. So the equation for our line is going to be y minus 0 is equal to 3/2 times x minus 0. And this is simply y is equal to 3/2 x. You can use a graphing calculator to graph a family of lines. So consider the family of lines y equals 0.5x plus b, where b can be any number, let's say. So what this means is we're graphing a family of lines where the slope is always 0.5 or 1/2, but it has different y-intercepts. So these are going to be a bunch of parallel lines, right? Because all of these lines are going to have the same slope, but they're going to touch the y-axis at different points. And so this is what a few members of that family would look like. Now, of course, there are many, many more members, so I can keep on drawing, additional members to this family by just choosing different values for B, okay? But you can think of this theoretically as just a family of lines that are all parallel to each other because they have the same slope. And finally, let's consider an application where we interpret what the slope of a line represents. So a swimming pool is being filled with a hose. The water depth, y in feet, in the pool, t hours after the hose is turned on, is given by the formula y equals 1.5 t plus 2. Find the slope and the y-intercept. Okay, so this part is relatively simple. The slope of this line is 1.5, and the y-intercept is 2. And now the second part. What does the slope and the y-intercept represent? Well, if you think about this as a graph, y equals 2 is going to be that point right there on the y-axis. And then the slope, 1.5, is going to give this line a certain amount of steepness. So this is your t-axis down here. This is your y-axis up here. T is time in hours, and y is depth in feet. Okay? So what's happening is, as time goes by, the depth is getting more and more, right? The depth is increasing. This is because more water is going into the pool, so it's deeper. So what does this represent? So the y-intercept right here, this represents when t equals 0. This is the beginning of when the water was turned on. So the y-intercept represents the depth when hose is turned on. So in other words, there was already 2 feet of water in the pool when this began. Okay? Now, what does the slope represent? So if I think of what is going to happen after 1 hour, how much water is going to be in the pool, we can plug that in, right? Y is going to be 1.5 times 1 plus 2. This is going to be 3.5. So in 1 hour, the depth of the pool is going to be 3.5. So notice that what happened there is the depth of the pool increased by 1.5 in 1 hour. So that is the slope, isn't it? So the slope represents the change in the depth per hour. So every hour that goes by, we are going to add 1.5 feet of depth to this water, right? That's what that represents. And that concludes this video lesson.